All right, welcome back. So we're next going to talk about modules. So this is the second topic of this lecture, and why do we have modules? So modules are something that is very useful in Python, and often it is said that Python is a language where the batteries are included. And so the reason it's said that the batteries are included is because Python has a large number of built-in functionalities that are able to do the things that you want as a programmer, and you can do them with very minimal work on your part, with very few lines of code. And the power of this comes from modules, and these are built-in libraries of code that work together to do something. And so you can either use modules that are included with Python, you can create your own modules, or you can use and download modules created by others in the Python community. So, someone might be working at a company like Microsoft or Google, and they might develop a set of code that does something. And instead of just using it on their computer at their company, they make it open source so everyone can use it. And this is one of the powers of Python, is this open source coding and kind of like this philosophy to share the stuff that you create. So what's an example of that? You might be familiar with machine learning. So machine learning has obviously become very, very important. And companies like Google, Microsoft, Facebook, etc., have started to use machine learning as part of their everyday programs and websites that they provide. So, an example of this is facial recognition software. So if you go on Facebook is able to automatically recognize some of your friends based upon just how they look in a photo. Self-driving cars. So the way self-driving cars are going to work is that there's going to be video information that is taken by the car, and then that has to be processed into some sort of like object detection. So when the car is driving, it can recognize, okay, that's a car, that's a bike rider, that's a sidewalk, etc. And so how does the computer able to do that? That is using this machine learning, some of these different machine learning algorithms that have been developed. And so you can actually use these as well, because those companies have supported the development of these open source libraries. And so now you can take all of the code that they develop, or not all of it, but like some pretty significant code that they've developed, and use it on your own computer. And this is great, actually. This is how I do research in my lab. So we use all sorts of these types of examples for my lab. And this has kind of revolutionized some of the stuff that we're able to do in our lab. So how do they work? So the way you use a module, so let's enter the interpreter. So now we're in the Python interpreter. So you need to import it, and you use the statement import, and then you need to provide it the name of the module that you want to import. So one of the built-in models, so Python comes with this code already included, but you can't use it until you import it. So what is math? So math is a module object now. If we use type, we see that is of class module. And now we can use dir, and we can see it acts a lot similar to all the other objects that you've started to grow familiar with. So like a numerical object, like an integer, like a string, like a list, like a dictionary. You can use the dir function to list all of the attributes or methods. And so modules also have both attributes and methods that you can use. So as an example of this, an attribute, so if we do math, and then we see one of these is called pi. This is just a shorthand way to have pi to maybe 10 digits, an accuracy of 10 digits. So if you ever wanted to use, what is the area of a circle, pi r squared, so you can just use this, for example, and you could calculate the area of a circle. Or if you wanted to calculate the circumference of a circle, you can use math.pi. So this is a lot easier, for example, to type than going and memorizing, all of these different numbers, etc. There's also a bunch of functions, exponential functions, trigonometry functions, so cosine, sine, tangent, arc cosine, secant, etc. So all these trigonometric functions are available for you to use. Square root, logarithmic functions of different bases. So you can have natural log. You can also have log 10, and so you'd use these just like you would any other function. So if I had 100 and I wanted to know what the log base 10 of 100 is, and you always have to remember to call it properly. So I can either get the natural log of 100, or I could use the log base 10, for example. And so the natural log of 100 is 4.6, blah, blah, blah. And the 100 is 2.0. So hopefully this is pretty straightforward. So if you know that you have some sort of math thing that you need to do, a little bit more complicated math than normal, then all you have to do is remember to import math, and then you have access to all of these functions that are included within this module. All right, you can rename modules if you want. So if you use the keyword, the as keyword, you can call it M. So if you get sick of having to write out this all the time, you can rename it as something shorthand. So this is also very common. We're going to see when you use modules, a lot of times you tend to rename them. Some of them you rename, some of them you don't rename. And if we do M, this is just a module. So one thing that's nice to when you just type M, it not only shows the module, that it's a module object, but it also shows the location of where this module is on your computer. So let's see that really quick. So if we start a new tab, now we can simply change directory into this location. Present working directory. So now we see we're in our home directory, opt. So this is where Anaconda installed. And now we see that there's this folder lib, library, and then there's also the version of Python that we're using, and then this just indicates the type of libraries that are within here. So you see that there's actually all sorts of different library files that are within here, and one of them that we use is math. So this is basically the location of all this code. So this is a special type of file, so you can't actually look at it. It's a binary file, so if you tried to look at it with more, for example, it would just be a bunch of nonsense. But this is actually just the interpreter knows how to interpret what this type of file is and then turn it into functions that you need. There's all these other ones. So socket is an example. So let's say I go back to Python and I import this other module socket, and then I type that. And so this is also a library, and some of it is stored in this file right here, socket.py. So this is a type of file that has a Python part, and this provides some additional facilities, and then also that are implemented in Python, and then it also is able to import this file in this directory right here as well. So kind of how modules are stored can be very complicated. They can be stored in these .so library files, or they can simply be Python files. So in general, what you're going to make is probably most likely just going to be strictly a Python module. So all of the code will be written in Python, but it's also able to use modules that are written in combination of languages. And so this is very important, for example, efficiency. So some of the modules that we'll use later in the class, like Pandas and NumPy, these are numerical Python and large CSV files, kind of like database type operations that you can do. And so you want those to be very efficient. And so those are efficient because some of the back-end code is actually not written in Python, but a much more efficient language. So hopefully that all makes sense. You have these different types of libraries that you can use, and you can also import them into your code. All right, so let's keep on going. So there's another library called sys. So sys provides a large number of things, but one of the cool things it does is that it has this attribute called path, and path is basically all of the different folders where Python looks in order to find a module. So whenever you say I want to import this module, what Python does is it looks whatever is in the Python path, and that is where it tries to find it. So you'll notice right here, this math module is stored within this folder, and then that's one of the paths that it looks for. So this should remind you of how path works in the shell. So we talked about using which, for example, to see where a executable file is located, and then we can also echo path, for example, to see these are all of the libraries where the shell looks for in order to run an executable. So very similarly, this is where the sys.path tells you this is where the Python interpreter looks for in order to run their modules. So they're separate directories, so you don't store modules in the same place that you store executables. So you notice that like bin, all of these executables are typically stored in the bin for the command line stuff, but for this, none of these are called bin, and that's because modules are different than executables. So if you want to make your own module, you can also do that. And also one final thing I thought I would mention before we get into that, you can also import individual functions or attributes from modules. So you're probably not going to use this as you're first getting used to Python, but you might see this, you might encounter this when you're Googling for help or you look at someone else's code. And so very often you might see something like this. And so whenever you see the import, you should immediately think module. I'm trying to import something from a module, but you might see it start out with this, from math import costs. And what are you doing there? So now what you're doing is you're just importing the cosine function and not anything else. So I can now run it. So instead of running it like this, like we normally would have to do, all you have to do is type COS, and so that's importing just that. So let's see how this all works in a little bit more detail. So if I run the dir function right now, this tells me all of the objects. So if I don't provide it with any sort of argument, the default way the dir function works is that it just prints all the objects that are available right now. And so I can see if I do x equals 2, so I've used the assignment operator to create this new variable called x, and now if I do dir, I can see that. So I can't right now call the cosine function. I can't use math at all. But let's say I do this, from math import cosine. So now I have access to the cosine function, and it's just called cos. So I can just call it like this. Again, I can't use math.cosine because this command right here is very specific, and it only imports one of the functions. But now if I import math completely and I look at what's available, the dir, I can see, oh, math is available, and now I can import it that way. So let's say you wanted to create your own module. So let's say there's some sort of code that you use over and over and over again, and you don't want to have to keep rewriting the code. So how do you create your own modules? And so that's very simple. So open a script, and now we're just going to add this line of code to it. So we've created a function called tokenizer. So this takes in two different arguments, A and B, and then it splits the string using the split command, and then returns the split word. So this is kind of like if you wanted to split up a sentence into words. And then we've also just defined this number kind of randomly called this. So if we save it, let's save it in our home directory. And we are going to call it Python class.py. All right, so now we see we have this code called Python class.py. We entered the interpreter, so you're not running it like a script. So just as a reminder, you know, when we were running something as a script, we would do something like this. But a module, you don't run that way. So you just enter the interpreter like normally, and now we just do import Python class. And it worked. So now we can see what Python class is. So it's a module, and it's stored in our home directory. What are the things we can do with it? So it looks like it has this thing number and tokenizer, and so now we can use it like this. And so you see this function runs, and then it returns a list of words within this sentence. We could also do this in order to access the number as well. So why were we able to import that successfully? Let's say we go to a different, so let's say we go to this directory. And so we're in the opt directory within our home, so the Python class.py file is no longer there. Let's say we try to import it now. Now we get this new error called module not found, no module named Python class. And so why is that? So that is because we tried to import it from a directory. It is not looking for it. So again, the sys.path tells you all the different directories that it looks for modules. And so one of the directories that it looks for modules is whatever directory you're running Python from. So that's what this business right here says. It says, look in whatever current directory I'm in. And so because the Python class is not in this directory, it's unable to find it. But when I run it from the same directory as where it's in, now we can import Python class without a problem. All right, so we've managed to import. And so one final thing just to mention is that you can actually define all of the, you can modify the libraries that Python looks for things by using this environmental variable. So this is a shell variable. This is something that you define kind of like we defined the path. But you can modify this, and this will change where Python looks for modules. So how does this work? So you're going to export. So this is something you run at the command line. So we're modifying a shell variable, and let's add our home directory. So this says add the home directory to the Python path. So let's see if that worked. Did I do that right? So now you see that this directory is included in the Python path. So now let's say I open Python. So now I see this is one of the directories that it looks for things. So if I go to opt, and and I run Python, import Python class. So now it works. So why did it work? It works because I modified the list of directories that Python looks for modules, and so now it's able to successfully find it because the home directory is one of the places that we look for it. If you want to make that change permanent, then you have to modify your configuration file in order to make this permanent. So, you know, if I exit and now I create a new terminal, my Python path reverts back to what's normal. All right, so finally, what is really useful are open source modules. So these are the modules that are created by others in the Python community. And this is one of the reasons that you want to use Anaconda, because Anaconda has a really good system for installing modules from other people. So let's see an example of this. So an example of this is requests. So we're going to look at requests. Is the name of the module that we're going to try to use. And so requests is a module that is really good at interacting with web pages. So let's say, you know, you certainly know Google Chrome. So let's say you use Google Chrome to go to a website. So if we go to google.com, you know, this is where it takes you to. Let's say you wanted to be able to write a Python script that takes data from a website and does something with it. So why might you want to do it? So in the times of COVID, you know, maybe you are following some of the COVID trackers, and you know, this information is kind of updated on a daily basis. So it's pretty easy in Python to be able to download this information into your script and then do something with it. So, you know, this is something I wrote something at the beginning of COVID, and, you know, I could track along and see where the cases were changing and, you know, where hospitalizations were changing, et cetera, and kind of get a sense of, like, you know, for which county do we see a lot of spread. And so requests is one of the modules that you would probably use for this, or if you don't use requests directly, you might use a module that uses requests. So how do we use this? So let's open Python 3 and let's try to import requests. And it looks like, sorry, I already downloaded that. So let me try this. So Pandas is another one that I use. So we So if you want to install requests on your computer, if it's not already installed yet, you simply use this conda command. So you type conda. So conda is the name of the command line that you're running, the command line program that you're running, and then you provide it this argument, install. So install is a argument, a parameter that it needs, and this tells you to install. You're going to install a module, and then you use a flag. So a flag is just, it's a channel. It's called a channel. -c is called a channel. There's a number of different channels that you can download these modules from, and you can specify them in the command line. So I'm specifying to use the Anaconda channel to download requests, and then the name of the module that I want to download is called requests. And so it looks for it and says, all right, the following packages will be downloaded, and do we want to proceed? And we type yes. And so now we've managed to install it. You know, we could also use the Conda Forge. This is another common one that people use, Conda Forge. And we can install, you know, we'll install Pandas now. And this might take a little bit of time. So I'll start a new tab while it figures that out. All right, so import requests. So requests, So this is installed in a different folder called site packages. So this is where your custom packages are typically installed in this folder called site packages. But you'll notice that you're in Miniconda again. So if you're familiar with HTML, if you want to get the information on a website, you use a GET request, and the GET request downloads all the information at that website that you provided. So HTTP : // that's usually how you access specify the website URL that you're interested in. So response 200, so if there's an error, it probably will not be 200, so if you mistype it, for example. And this is not the right thing I should search for. I'm sure there's something parked at google.com. If you type something that so if you type something that is not an actual website, you get an error. And so if you try this on using requests, you get an exception because it's unable to find kind of the website that you're looking for. Some other types of error that you might find are if you go to a website that's real, google.com, but then you request a site that is not actually available, then you get a 404 error. So you notice that the response is a 404, and so you can actually look for that and see, okay, I requested the wrong website. But let's say you did request the right website, then this is some of the information, for example, that the website sends back. And then websites send back HTML data, so this is HTML right here. And so this is what the website sent back. Your Google Chrome, knows how to display this, how to render this as like a web page, but this is actually the data that Google sends over to you in order to create this web page, and this is in a language called HTML. All right, so we're not going to really get into the specifics of web pages, and we will use some Python code that makes it really easy to get data from web pages. But if you are at all interested in doing any sort of like web page stuff, like this request library, for example, can be very useful. It returns all the information stored as different variables. So you'll also notice that this object, so what is created by this function, that we stored as an R variable, this is called a request.modules.response. So this is a brand new object that we haven't seen, and this is actually defined, this object is defined by the makers of the request module library. And so this is just another object, and we can see all of the attributes and methods that are available within this object. All right, so we've gone over some of the basics of modules. So you can either use modules that are built into Python, you can create your own modules, or you can download and use modules that are created by other people.